Okay, what we're going to do here is we're going to look at inscribed angles. What an inscribed angle is, it's an angle in a circle where its vertex is on the circle and so are the two endpoints. So if you look at this circle here, you've got one inscribed angle in it. You've got angle CBA, or you call it ABC. That angle is inscribed. Its vertex is B, and the two endpoints are C and A. This D in the middle, this is just to tell you what the center is. This is called circle D, with inscribed angle ABC. Let's look at some information that we're given. We're given that this arc, BC, is 70 degrees. We're given that this angle, ABC, our inscribed angle, is 73 degrees. What we know about inscribed angles is that whatever the measure of the inscribed angle is always half, exactly half, of the arc measure. Okay, the arc that it cuts off, the intercepted arc. So how we're going to do these, use some colored chalk. We are going to trace the angle so we can find out what the arc is. So let's trace our angle. Angle ABC. A to B to C. This angle right here. You see the vertex is B. And all that means the two endpoints are A and C. I want you to trace that arc from A to C. Trace from endpoint to endpoint. A to C. Well, this is going to help me because I know the arc, the measure of that, is double the inscribed angle. Or you can say the inscribed angle is half of the arc. So you're asking yourself what number, when you say half of it, gives you 73. Well, double 73, multiply it by 2. 73 times 2, 146. And that's that. We know what that arc is. Alright, so for instance, if there was a question mark here, we'd know that now that measurement is 146. AC is 146 degrees. The other thing that I might ask you is maybe what's arc AB? Well, we know a couple facts about circles. An entire circle has 360 degrees in it. Or a half circle has 180 degrees in it, or a semicircle. Right here we don't have any diameters, so we don't have a semicircle. I have a full circle. And if I know from A to C is 146 degrees, and from C to B is 70 degrees, I should be able to figure out the remaining piece from B to A. What you're going to do is you're going to add these up and subtract that from the sum. Subtract that from 360. Well, 146 plus 70, that's 216. And 360 minus 216 will give me the rest right here. This should be 144. That's that. Okay, that circle's done. The way you can check it, 144 plus 146 plus 70, that should give you 360. 144 and 146 is 290. 290 plus 70 is 360. That's done. Let's move on to the second circle that we have here. Use red chalk for this one. Use the purple. Here, again, you've got some inscribed angles. This time we have more than one. This is circle I. We've got 3 inscribed angles. We've got a triangle inscribed in the circle. So we've got GFH, that's one inscribed angle. We've got FHG, that's another. And HGF, that's the third inscribed angle. What we're going to do here is we're going to identify which angles we know, which arcs we know, and which angles and arcs we can find. So let's start with an inscribed angle we have. Let's start with, here's an inscribed angle, a G. FGH. This is an inscribed angle. I'm going to trace it. I see my vertex is at G, and I see that the arc that it cuts off, its intercepted arc, is FH. So color that in. And the coloring is really optional, but it does help you see them. So I know that this is the inscribed angle. This is the arc that it's intercepting. Okay? The inscribed angle is half of the intercepted arc. So if this is 60, I need to ask myself what number, when I take half of it, do I get 60? So if you multiply this by 2, you get the correct arc. 60 times 2 is 120. So I know that arc FH is 120. That looks bad. Is 120. That's better. Okay, well we have some other arcs in this picture, some other pieces. First thing you could do is now you see if this is 120 and this is 160, I'm only missing one piece of the circle left. So one easy thing that you could do is say that all of the arcs should add up to 360. So if this is 120 and that's 160, I can subtract those from 360 and find out what this missing arc GH is. Let's see. 120 plus 160, that's 280. and 360 minus 280 is 80. So we know that arc GH is in fact 80. We can get these two missing angles. It doesn't really matter which way you do it. You can use inscribed angles, you can use your triangle rule, anything you'd like. Right here, first, I'm going to get this just because I can. This is an inscribed angle, angle FHG. We see yellow now, FHG. That's the inscribed angle, and it cuts off this arc. Only focusing on the yellow. I see the arc FG is 160. The inscribed angle has to be half of it. So if this is 160, half of 160 would be 80. Okay. There is one other arc we can worry about. I had green chalk. There it is. I've got one more inscribed angle. I'm going to do this kind of squiggly. You've got this inscribed angle here, angle GFH. Well, you see that GFH, its vertex is F. The arc that it cuts off is GH. And this time we know it. GH is 80. If GH, the arc, is 80, the inscribed angle should be half of it. So half of 80 is 40. A second way you could have gotten this 40 is once you knew these two angles, since this is a triangle, its degree measure is better add up to 180. So 80 plus 60, well, that's 140. And 180 minus 140 is 40. Any way you want to go about it, you still get the same answers. All right, that's two problems. We're going to look at two more.